Right, so just as we saw in double integration, you don't have to integrate over a rectangular box, or I guess a rectangle on a plane. Here, rectangular box. So again, if you've got a continuous function, you can take a general integration over R3, and the R3 stands for the third dimension, real numbers in the third dimension. Okay, don't get this confused with R2, which is the real plane, or R, which is the real number line. Okay, so the only difference here really is that one of these things is going to be a function of another. So you've got to make sure that you are paying attention to that. So in our example down here, our y value goes between cosine of x, and I guess negative cosine of x and cosine of x. So that's going to be a function of x, whereas the x and the z values go elsewhere. Now, we can set this up however we want. I'm going to suggest doing the z first because there's no z component anywhere in this. So we've got sine of x plus sine of y. There's no z. We can do z first to make that part pretty quick and painless. So this is going to equal, let's see, I think we should probably do x last, so let's do r0 to pi by 2. We'll do the y next, so negative cosine of x to cosine of x. And our z first from negative 1 to 1. And that's sine of x plus sine of y. So that'll go dz, dy, dx. And I'm going to be doing the inner part first. Again, nothing here has any z involved. So this is really just sine x plus sine y times z, but that's a constant, so I can just do this. And I'll have one of them, and I'll subtract negative one of them, so that'll just equal 2. This part here equals 2. So this is going to be 0 to pi by 2, negative cosine x to cosine x. And this is, and I can pull a 2 out. I'm just going to put the 2 out front. This 2 is going out front. All right, so now I'm going to do the y component. Sine of x is going to be a constant in this case. So this is going to give us sine x times y, and then plus the integral of sine is negative cosine. All this goes from negative cosine x to positive cosine x. All right, so here we have sine x cosine x. Minus cosine of x squared. Excuse me, that is incorrect. That is going to give us minus cosine of cosine of x. That's what that is. And this is going to be subtracting sine x times negative cosine x. I'll put the negative there. And then this is minus cosine of negative cosine of x. That's all dx. So can we clean this up? We're going to have to because it looks like a hot mess actually. All right, so we've got a sine x, cosine x, and a sine x, cosine x, and because of the minus, we have a minus minus, which will make it a plus, so that gives us 2 sine x, cosine x. That's that part. And the other stuff. Let's see. Minus cosine of cosine x. And cosine of net, well, cosine, so this here is going to be the same as cosine of x, because cosine of a negative is going to be the same as cosine of the regular, given the even function. So this is going to be minus cosine of cosine x, and then plus cosine of cosine x. So it did clean up. This goes to 0. Okay, so we can, pick either one of these to be our u, essentially. But let's see. Let's let u equal sine. Here, let's do this. Sine of x. That means du equals cosine of x, dx. So, and we've got a 2 and a 2, so that'll give us 4 out here. And we're integrating just u du essentially. So this equals 4 u squared over 2, which is going to equal 2, and the u here is sine, so sine squared of x, and this is all evaluated from 0 to pi by 2. And this is going to equal 2 times sine of pi by 2 is 1. So 1 squared is 1, so we have sine of pi by 2 squared minus sine 0 squared, which is 2 times 1 minus 0, which is 2. So that should be our answer.